Well, hello guys, here Mr. G with another video. This time is going to be for the grade 12, and finally we're starting with videos from paper 2. This one was done in September 2023 in the Eastern Cape province, and I'm going to leave the question in the description below so you can answer the question before watching the video. However, the table, I'm going to keep it here, so you will have to be using the description and the table. But before we start answering the question, don't forget to subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question says, consider the organic compound A to F below, and then you have a few organic compounds. In this case is 6. And before we go on, let's identify the type of compound in each of them. A ends in "in", so it's an alkene. A is an alkene. B have a OH here, it will end in OH, and therefore is an alcohol. Is an alcohol there. Here we have oic acid. This one is a carboxylic acid. This one is a carboxylic acid. D is a triple bond, is an alkyne. E have a double bond with a carbon and single bond with a H at the end, so this one is an aldehyde. And then we are having here a haloalkane. Haloalkane or alkane halide. So those are real fast. It didn't take me like nothing to do this one and identify the type of compound of the homology series to each of the different compounds. Now we're going to start answering the question. 2.1, write down the letter of the compound that is an alkyne, and we already respond this one. That one is going to be compound D. Okay, you can see I have a triple bond between carbon. That is the functional group of alkyne. We have is a haloalkane, is a compound F, guys. You can see the compound F. You can see have a halogen in the as the functional group or within the carbon. So remember, the functional group will be a carbon that has one halogen in it, which I'm going to call it X. Alright, that one will be the functional group for haloalkane. Has a general formula of a CnH2n plus 2O. And then we are looking for a compound that have and then guys, here is a tiny problem with this question there. This general formula, if you see, there is 2 oxygens there. The only compound that have 2 oxygen is the carboxylic acid. However, this is not the general formula for carboxylic acid. So here, the only thing is that there was a mistake and they wanted a 1 oxygen. And if that is the case here, then this will be the general formula for alcohol, and then the compound will be B. So the answer here is B. Be careful with that one. There is a tiny, mistake here. This should be 1O. Okay, and that will be B, which is an alcohol. Is compound A saturated or unsaturated? Give a reason for your answer. So we're going to compound A. Compound A is an alkene. The functional group of alkene is carbon double bond to carbon. Okay, that will be the functional group for alkene. Let's fix this bond there. There we go. And then that one is a unsaturated hydrocarbon. So it's an unsaturated because it have double bond between the carbon there. So A is unsaturated. Give a reason for your answer. There is double bond between carbon atoms. Well, that is the explanation. What is unsaturated? Because it contains double bond. If they say a double unsaturated hydrocarbon, then it's double bond between carbon. That's right here, carbon atoms. Okay, but they don't ask for hydrocarbon, they ask for a general compound. Question 2.3, write down the structural formula of compound C. So compound C is the carboxylic acid. So we are going to go to a new page. There's no space for this answer here. Alright, here is the compound, and we are going to write the structural formula. When we write in the structural formula, we must always identify the compound. Here is a oic acid. We already did that, and it's a carboxylic acid. Now, what is the functional group of carboxylic acid? The structural formula of the functional group will be a carbon double bond oxygen, single bond oxygen, and then hydrogen. This one is the functional group for carboxylic acid. Now what we're going to do, we are going to count how many carbons are there. And then if you come here, it has pent. And pent is 5 carbons. So it has 5 carbons. Now 5 carbons counting the functional group. So it's 1 with the functional group, 2, 3, 4, and 5 carbons, and I will do all of them in a line. Let's fix this one here. 1, 2, 3, 4, and 5. All of them are along a line. 1, 2, 3, 4, and 5 carbon. Now we are going to the substituents we have here. In this case, we have a dimethyl, and they are in carbon 2 and 3. Now remember, the first carbon will be the one of the functional group, so will be 1, 2, 3, 4, and 5 in that specific order. And in carbon 2 and 3, they are 2 methyl. So in carbon 2, which is the second one here, you will have 1 methyl up. This one is C, H, H, H. And then in carbon 3 is another methyl. I'm going to draw it down here. So it's a C with H, H, and H. And then the rest of the question is just joining the carbon, and make sure you do have 4 bonds for each carbon. So I'm going to join the carbons there, and there, and I'm going to start adding the hydrogen. So the carbon here have 1, 2, and 3. And 4 with the other carbon. The second carbon have 1, 2 with the 2 carbons, 3 and 4. The third carbon has 1 top. There we go. And now this is complete. And here we are. This one is the correct answer for 2,3 dimethyl pentanoic acid. It's quite simple. It's easier to draw structures than writing the name. This one is question 2.3.1. Now, question 2.3.2, write down the IUPAC name of compound D. And now compound D is the alkyne here. So let's go to the new page. Okay, and here we are. This is the compound and we have to write the name. Now, we are going to follow certain steps. And the first step will be identify the homology series, which we actually did. So, the homology series is an alkyne, and therefore it will end in -ine. That one is the first part we're going to have here, like the first data. So in this second step, we're going to look for the longest continuous carbon chain that has the functional group. Guys, now note the following. At the end of the carbon in the stream, you cannot have alkyl groups. Alright, so those will come like a longest continuous carbon chain. So if I do that, I have here, for instance, a carbon on this side. So this one I'm marking will be the longest continuous carbon chain. And if I count the carbon, I just have to need to count to know how many there are. If you count, you have 1, 2, 3, 4, 5, 6, and 7. So I have 7 carbons. 7 carbons. And 7 is hept. So that is the second step we have. So we have the end of the name, we have hept. Alright? Now, the next step, we're going to count the carbon starting from the end nearest to the functional group. Okay? So if we count from the left, we have 1, 2, 3, 4. The triple bond is in carbon 4. If we start from the right, 1, 2, and 3. So our first carbon is going to be 1, 2, 3, 4, 5, 6, and 7. Those are the 7 carbon in that specific order. And now we are coming back to the step 1, and we are going to write in which carbon is the triple bond. This is an important step that children or people attempt to forget. So this one is in carbon 3. So instead of being -ine, it's going to be 3-ine. That we fix it there right now. Okay? And that one was step 3. I'm going to write here number the carbons. number the carbon. Step 4, and I'm going to write substituents. When I mention substituents, guys, this one could be, for instance, halogens. It could be methyl. It could be ethyl. Those are examples of substituent. In this case, you can see it is a clean structure, so there is no substituents, and therefore this one is done now. If we have substituent, then we have to use the prefixes di, tri, and tetra, but we don't have any. So we combine the names, and all we have is hept and ine, nothing else. So the correct name for this compound will be the combination, and is hept 3 ine. That is the name of this specific compound. That's it. That is easy. It's not difficult. I went a little bit long. Of course, when you answer in the question, you don't have to go that long. You will learn the steps by memory, okay? And that was question 3.2.1. Let's write it here perhaps. Hept 3 ine. That was the answer for that specific question. You know, marking wise, we'll keep forgetting. There is 1 mark for each of this one here, so it's quite simple. Okay, obviously this one may be a problem because the general formula is wrong. Okay, so that one should be a problem. Here is 2 marks, 1 for say unsaturated, and then 1 mark for say it contains a double bond. Now in the case of the drawing or the writing of the formula, this one here, you will get 1 mark for the functional group to be shown there properly. There's 1 mark for that, and the rest of the mark is for the whole structure correct. So if everything is correct, you didn't forget any hydrogen, any single bond, you'll get the 2 marks. There is not so many marks. And this one is 2 marks for the whole name, so it's 2 or nothing there. And that is the mark, these 2 marks here. So now, is compound B a primary or secondary or tertiary alcohol there? Now what you need to remember is about the primary, secondary, and tertiary alcohol. Okay, everything have to do with the OA, which is the functional group. If the OH is bonded to a carbon which is bonded to only 1 carbon, that one will be primary. If the OH is bonded to a carbon which is bonded to 2 carbon, then it's a secondary. And if the OH is bonded to a carbon which is bonded to 3 carbon, is a tertiary alcohol there. Now here we having a carbon that is bonded to OH, but we don't know because it is not a structural formula. So the first thing we're going to do is to draw the structural formula of that compound, and we're going to do it right here. So what we have there, carbon, there is the OH bonded to that carbon, and then there's a bracket with 3 CH3. The 3H3 are bonded to the OH, so it means there is 1 CH3 here, which is there, another 1 here, and another one, this is a 3, and another 1 here. So you can see that this carbon is bonded to 3 other carbons, okay? Remember, if we do it structural formula, it will be like this. Maybe it's better for you to see. This one is hydrogen. This one will be like this. And this one, just in case somebody get confused. As you can see here, this carbon, let me show you here. The OH is bonded to carbon, and the carbon is bonded to 1, 2, and 3 carbons. So guys, this one is a tertiary alcohol. Now what I want you to do, I want you to not be in a hurry. So do the structural formula. It's a tertiary alcohol. So it's a tertiary alcohol, and you will get 1 mark for saying that. And then for the explanation, the carbon that is bonded to the OH is bonded to 3 other carbons. And if you say that, you'll get another mark. 1 for saying tertiary, 1 for explaining. I have a video done on type of alcohol. I will leave the link here so you can see it. Question 2.5. Write down the IUPAC name of the chain isomer of compound B. Okay, now for this question, we have, this is the compound. This is not what they want. This is the compound. Remember, we just did the structural formula to get a better clarity of the compound. What is the name of this compound, by the way? This one is quite simple. We have the longest carbon chain like this one here, and it's a ol, so it will end in ol. All right. We have that is F, but because it is a alcohol, so we're going to write ethane. There we go. If we number the carbons, this will be carbon 1 and this one will be carbon 2. So saying that, we also have 1,1 dimethyl. You can see that is 2 methyls in the first carbon. There is 1 and there is the second one, and all of them are connected to the first carbon. So that's all we have, and then when we give the name here will be 1,1 dimethyl ethane 1 ol, because this one is in carbon 1, ethane 1 ol, but it can be only in carbon 1, because if you move it to carbon 2 it will be a longer chain, which is what we are going to do actually right now. Dimethyl ethanol, that is the answer for this compound, but this is not what they want. I'm looking for the highlighted. This is not what they want. What they want is actually the chain isomer. There is also a video done on chain isomer. This could be tricky. Now, the chain isomer is a compound. Let's write it down here in the new page. Actually, I moved too far. Let's write here what is a chain isomer. So, a chain isomer is a compound that have the same molecular formula but different chain. Guys, the molecular formula of this compound, this is the molecular formula for this compound. All we have to do is to change the chain of this compound. So how we are going to do it? Instead of having 2 methyls in the first carbon, I am going to move one of the methyl to the second carbon, and that will make the chain a little bit longer. So let's do that real fast here so you can see. This is what we have, OH, and we have here double methyl, but I'm not going to have 2 methyls now. Instead, I'm going to have only one, and here is what we have. I'm going to move here to the second carbon. Look there, in the second carbon I'm going to move the other methyl. So here will be a carbon with the 3 hydrogen. So now we complete, make sure every carbon have 4 hydrogens or 4 bonds, let's say. This is the chain isomer. They don't want the structure, they want the name. So this one still going to be ol, it's an alcohol, still going to now the number of carbon changed. The longest carbon chain this time have 1, 2 and 3. So instead of ethane, it's going to be propan. So this one is going to be propan. Remember, because it's an alcohol, instead of prop you add an. There is a video of also writing name of compounds in details, guys. Okay, this is alcohol. Okay, propanol. Now we are going to give numbers to the carbons. So this one is carbon 1, 2 and 3, and in carbon 1 you have a methyl. So you have 1 methyl. Let me go something here. There we go. It's 1 methyl, and then the rest is just combining. So the name of this compound will be 1 methyl propan ol, propanol. Okay, okay, in this case you will have to say in which side is the functional group, which is in the first carbon, 1 ol. That is the correct way of giving the IUPAC name of this specific compound. And this is a chain isomer of the original one. Is it the only one? Well, no, because we can move the other alkyl group, the other methyl can be moved now to carbon 3, and instead of a propan we'll have butane. So instead of this one you could also do it like this. For instance, 1, 2, 3 and 4. Here is the OH, we're going to keep it in the same side, and this could also be a chain isomer of the first one. There were 2 options here. So if you select this option, this one is quite simple, because we butane 1 ol. This is another option you can take for the chain isomer of this compound. Remember, they ask only for the name. We did write the the structural formula to get clarity, but this is only the name. So there is 2 marks for the name, either this one or this one. Both of them are correct. Make sure at the end you calculate or you write the molecular formula. So let's make sure it was C4H10. So we have 1, 2, 3, and 4. C4H, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, H10O. And if we do here, we have it exactly the same. C is 4, H is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then 1O. All of them have the same molecular formula but different chain. Now, question 2.6 say compound E has a functional isomer. Guys, there is a video on functional isomer. I leave the link. It's quite important and it could be tricky. What are functional isomers? Now, functional isomers are compound with the same molecular formula but different functional group. That is functional isomers. And there are 2 marks for saying that. Quite simple. Write down the condensed structural formula of the functional isomer of compound E. Now, what is compound E? Is an aldehyde. The functional isomer of an aldehyde will be a ketone. So guys, in terms of functional isomer, we have ketones, an aldehyde. When I mean ketone and aldehyde means that the functional isomer of a ketone will be an aldehyde and the functional isomer of an aldehyde will be a ketone. But we also have carboxylic acid and esters. In other words, if you want the functional isomer of a carboxylic acid, you're looking for an ester. And if you want the functional isomer of an ester, you're looking for a carboxylic acid. In this case, we're having an aldehyde here. We're looking for a ketone that have the same number of carbons, the same number of hydrogen, and the same number of oxygen. Guys, a ketone, all we're going to do is to move the functional group to the middle, and that's all. Okay, so this is what we have here. This is aldehyde. But how we make this one a ketone? Quite simple. All we have to do is to move the functional group to the center. So we have 1, 2, and 3, and here is going to be the functional group. This one will be now a ketone. Quite simple, easy. Now they don't want the structural formula, they don't want the name, they want the condensed structural formula. So to do this one, I'm going to do this one first so I don't make mistakes, and I'm coming here and I'm going to write the condensed structural formula. Guys, C with 3 hydrogens, 1 carbon with 1 oxygen, and 1 carbon with 3 hydrogen. This one is what they want. It's very simple. And this is the end of the question. If you do that, you get 2 marks. Guys, this question is a very good question, and I think all of you can easily get more than 60-70% in the question. There could be 2 or 3 tricky things, but the question is not that bad. So I hope it helped. Try to do the question by yourself and then mark the question with the video. Thank you for watching. Thumb up, subscribe for the channel. Next time we are going to be solving question 3, which is related to physical properties of organic compound, which could be a little bit tricky. Thumb up, subscribe for the channel. See you next time. Mr. G here.